we're going to learn about inverses, how to calculate inverses, and the fact that an exponential function is the inverse of a logarithmic function. Eureka has this weird thing that they're doing here. It's not weird, it's cool, but I've got a better example. So I'm going to do that for you. The idea is that an inverse takes the domain and range of a function and switches it, right? So we have our domain, we have our range, right? So if -2 is the range of f, if we make it the domain of g, and this is actually, we're going to use a different notation. The inverse we're going to call f inverse of x, okay? So that is some new notation. Not sure why Eureka decided to not have that notation, but it's very important. And it's the notation that you would see in a college course. And I would hate for you guys to go on to your college course and have them talk about inverses and you be confused when you actually know what it is. So let's use that notation. So then it would make sense that I should put an 8 here, right? Right, because I have a 3 here and an 8 here. We're going backwards, right? So 8 should now be, what in the world? Sorry, the 3 should be 1. My brain looked at something weird. Sorry. 3 should be 1. 8 should be 3. 9 should be 5. And 15 should be 2. You see they're just reversed. I'm going to give you a way better example here, okay? It's okay. You could reverse these. It's all good. But what if I had the function yeah, you could. Yeah, this is the inverse of x. That's better. So, what if I had a relationship? We could say it's a function. It looks like this: 1, 2, 3, 4. If I input 1, it outputs 5. If I input 2, it outputs 10. If I input 3, it outputs 15. And if I input 4, it outputs 20. What do you think f of x is? 5x, right? You got to multiply it. Yeah, good call. So then the inverse of that, if we're going to switch it, so we have x and f inverse of x, it should look like this: 5, 10, 15, 20, and it should output 1, 2, 3, 4. What do you think f inverse of x is? How do you get from 5 to 1? Or from 10 to 2? Yeah. You're going to divide. So this would be what? It would be x over 5. That's what would do it, right? If I divide whatever x is by 5, I get my output f inverse of x. And that makes sense, right? Don't you think? Like, the way I think about inverses is like what undoes it, right? What undoes multiplication? Division, right? What undoes addition? Subtraction, right? Those are inverses. So what undoes, if I square something, what undoes x squared? Square root of x, right? That turns out to be the inverse. So that's what these are. So the heart of the lesson is showing you that what undoes a logarithm? An exponential function. What does undoes an exponential function is going to be a logarithm, okay? So if you're trying to find the inverse of some sort of exponential function, it should turn out to be a logarithm, right? I'm going to show you how to calculate that. Peter is Peter's not smart. I'm not going to say he's a loser, because just because you're not smart doesn't mean you're a loser. There are plenty of people that are. I am smarter than a lot of people that make a lot more money than me. So
But y is in the middle. So who's really the smartest person you know?
I might not be wiser.
Probably are.
I know stuff. I know stuff. But
You know it's so good not to eat almonds. I mean, you're
I clearly don't. I clearly don't.
No, so, you clearly do now.
I do now.
You did it at first. Those guys know that? I don't think so.
Do you still eat almonds? No.
I wonder why. It's almost like I tried to kill him.
Other stuff. For real. Okay. That's really the main thing about it. I want to show you guys how you can, without the points, how you can get from f of x to f prime of x, just real quick. Or, sorry, f inverse of x. Sorry. Catch me if I do that. So I'm going to write down some steps. I'm going to tell you how to do these things. These are the same steps every time. So if I have f of x equals 5x, okay? And I want to find the inverse. Step 1. I am going to let f of x equal y. They're the same thing, so it's fair. So instead of f of x, I'm going to put a y equals 5x, okay? Step 2, I'm going to substitute y for x and x for y. In other words, everywhere you see an I, a y, make it an x. Everywhere you see an x, make it a y. Step 3, solve for y. So now we're going to solve for y. How do we solve for y? Got to get that 5 to go away. We'll undo it with division. So if I divide both sides by 5, I get... That's on my brain. Dividing by 5, I get that y is equal to x over 5, right? Because those cancel. And that's what we got, right? The last step, step 4, we're going to use proper notation. So we're going to write it as f inverse of x is equal to x over 5. We're going to do a bunch of examples of that right now.
So,
yes.
So basically, you could kind of shorthand solve them because we've kind of done these before. Sort of. Finding.
I'm going to show you. They get
Okay,
way. I'm
giving
giving you. No, I know. I'm giving you a really simple example. They get harder. Because it's like life. Just when you think everything's great, it gets hard. Okay. Here we go. Make sure that you know how to do these. All right. Let's find an inverse of the number, step 1. So I'll still write the steps for this one, okay? Step 1. Let f of x equal y. So I'm substituting y for f of x. Step 2. Substitute x for y and y for x. So this y becomes an x, and this x becomes a y. Step 3. Solve for y. First thing I need to do is subtract 1 from both sides, right? So I get x minus 1 equals negative 4y. Next thing I need to do is get rid of that negative 4, right? Right? So there we go. Step number 4, we're going to use proper notation. So we get that f inverse of x is equal to, and you can simplify this. You don't have to. You can just write it as x minus 1 over negative 4. It graphs fine. Yeah, but we're going to get out our handy-dandy graphing calculator for that. All right, so our two functions that we had. All right, so we have 1 minus 4x, and we had x minus 1 over negative 4. Make sure to put this in parentheses if it's in your numerator. And the negative 4, make sure to use this minus key, okay? I'll put it there though. Alright, and we hit graph. And remember, I said that the inverse switches the domain and the range. It switches the x and the y, right? So for this one, the red guy, we have the point 1, 0, right? And on our blue line, we have the point 0, 1. Makes sense, right? Your x and your y's are all switched. Yes. That's because you did not, I think, put the x minus 1 in parentheses in your numerator. I don't want these here. All right. Cool, we graphed them both. Awesome. And then we're just going to graph them on the graphing calculator. I'll have you guys on Monday do a project where we'll graph them together by hand. Okay, let's find the inverse of this one. Step 1. So now I'm not going to write out the steps. I'm just going to talk them out. Okay. Step 1. Let f of x equal y. Step 2. Everywhere you see a y, make it an x. Everywhere you see an x, make it a y. Now, step 3, solve for y. So I'm going to add 3 to both sides. I'm going to actually write that out. Sorry. So I'm going to go plus 3, plus 3. I can't add an x to a 3, so it just becomes x plus 3. How do I undo a cube? Cube root. Nice, guys. Sounds good. And there we go. We did it. It's been solved. So let's go ahead and lastly use proper notation. So it's going to be the cube root of x plus 3. So it looks real bad. I'm going to make it look better. I'm not changing anything. Just the location of that 3. I didn't like it sitting right over my equals. there we go. We found the inverse of x cubed minus 3. Let's graph them. Ready? Okay. I'm going to go to my handy dandy calculator. I'm going to clear out this stuff that's over here. I'm going to put x. No. X cubed. Darn it. I am slow. Hey, if you have a regular 83 calculator, or sorry, yeah, you probably don't have that root function, right, where you can change the root. But we can use what we know about rational exponents to write it with a rational exponent. So the way that I write a cube root with my calculator is I put x, what was it, x minus 3 or x plus 3? X plus 3. And I raised it to the, and guys, if you have that calculator, if you're going to raise to a rational exponent, you got to put it in parentheses. Like that. Right? That's the same thing as the cube root of x plus 3. And you hit graph. Look at that. Yes. Well, what do you got there? No, do it like I did it. So do it like this. I'll pause the video. All right, that's pretty. Let's do another one. And this is really getting down to what the lesson is about, right? The inverse of a logarithmic function is an exponential function, and vice versa. There's also quite a bit of crazy math involved. Okay? A lot of algebra. So number 1, let f of x equal y.
Excuse me.
Okay. Now, number 2, substitute every y for x, and every x becomes a y. Now we got to solve for y. First thing I want to do is I got to take care of all this stuff that's going on with this logarithm. I want just log of y on one side. That's my goal. I just want this side to only have log of y. Okay? So, first thing I want to do is get this 2 out. If that 2 goes to the front, I got to multiply it by the 3, right? I'm going to actually write it. So if I bring it out to the front, it's actually 2 times 3 log of y, right? If I bring that bad boy out to the front, so that becomes 6 log y. And then I really want that 6 to go away. It's multiplying my logarithm. So to undo it, I've got to divide both sides by 6, right? That makes those cancel. Then I'll write this up here. So I get x over 6 equals log base 10 of y. All right. Now, how do we get the y out of the logarithm? We got to turn it into an exponential equation, right? So since this is log base 10, we're saying that this equation says the same thing as 10 to the x over 6 power equals y. Y, remember that? Remember we said that log base b of x equals L is the same thing as saying L, sorry, it's the same thing as saying b to the L equals x. We did that a bunch of times, right? That's why we're able to do that. You should have kicked it in there. Do your bands have Mardi Gras beads? Alright. We have solved for y. Now let's use proper notation. Yeah, it's not part of the answer. I'm telling you why I went from this step to this step. This is the justification. Just a refresher, you should be fairly comfortable with that one. Maybe not. So you're gonna put it there in case. Let's go ahead and graph them. What is it? It's 3 log base 10 of x squared. Darn it. Dang it. These graphs are very pretty in my opinion. They're very nice to look at. This one was 10 to the x over 6. And remember, if you don't have an updated operating system, you have to put the x over 6 in parentheses, okay? So if you've got an older calculator, make sure you do this. Ooh, it just makes all these cool graphs, right? And the reason why we have this weird blue fountainy graph, right, is because think about log of x squared. If x is negative 2, right, I get log of 4, right? And if x is 2, I get log of 4. So that's why we have this mirror image here, right? Just like why a parabola looks like that. We have something that looks like this.
So does it say we have like 2 possible solutions?
Yes. The real inverse is going on if we ignore what's going on to the left of the y-axis. That's kind of really what the inverse looks like. They kind of flip up there. They reflect about a line. Let's do another one. This one's a lot better. I like it more. All right, number 1, let y equal f of x, or let f of x equal y. Everywhere you see an x, put a y. Everywhere you see a y, put an x. Switch them. Now we have to solve for y, right? Solve for y. We want it to say y equals something. So, golly, gosh. I would love it if we could make these both base 2, right? But we can't, because there's no way I can make x base 2. So if that's the case, what we need to do is take the log of both sides, right? I think I'm going to take log base 10. Log base 2 would... No, I'm going to do log base 2. It's better. If you have the calculator to graph it, it's good. But the reason why I want to take log base 2 is because that, right? Because that base is 2. So I'm going to go log base 2 of x equals log base 2 of 2 to the y minus 3. And now I'm going to use my properties of exponents, my properties of logarithms, sorry. to bring this exponent out. And now you'll see why I chose log base 2. Because what is log base 2 of 2? 1, right? So it just went away. It's awesome. I love it when stuff goes away when I'm doing math. Hate it when stuff goes away and I'm paying bills. Unless the bill went away. That's a terrible analogy. What? What don't you get? My analogy or the math? Yeah, it was a bad analogy. Really bad. So now I just need to add 3 to both sides. So I get log base 2 of x plus 3 equals y. And we're pretty much done, except for to put it into proper notation. Just switching the sides of it. All right. If you don't have a calculator that does the log base 2, who doesn't have a log base function? Okay. All right, we're gonna have to change the base of it. We'll have to change the base. Let's do it real quick before we go to calculating. So this log base 2 of x is going to become log base 10 of x over log base 10 of 2, right? That's how we change the base. And now we can graph it on any graphing calculator. It doesn't have to be fancy. You're fancy enough. No? Okay, fine. Fine. I thought you were fancy, but okay. 2 to the x minus 3 power. So let's go ahead and graph that. And again, if you have a lower operating system, please do that, put it in parentheses. And our next one was log base 10 of x divided by log base 10 of 2 plus 3. Ready? Everybody's ready? Okay. And everybody was like, Jesus. It looks like it, but in actuality, right, this thing goes down like that. So there we go. They're pretty. I really like inverses. I think they make really, really nice graphs. And I think when we get to the point for the next class, when we're graphing them by hand, I think that you're going to enjoy it. We're actually going to do some graphs